So today we'll be doing Leetcode 11, container with most water. So you're given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I0 and I of height, okay? Find two lines together with the x-axis, form a container such a container holds the most water. Return the max amount of water a container can store. Notice you mean a slant, okay? So the vertical lines are the heights, and the indexes are, I would assume, the numbers. Okay, yeah. So we want to find the container with the most water. This looks like to be a rectangle, right? A rectangle. So container with the most water, maximum water. We're thinking area, right? So off the back of our head, if we're looking at a rectangle, right? The formula for an area of a rectangle, A equals, we're gonna do the base, so that would be the width, times, so width is this, and then we'd want length or height, width times height, right? So this is what we have. So let's look at an input, right? So we have, this is drawn 1, 8, 6. Okay, so this represents this. Okay, great. So input height given array, right? So you're given, so output is 49. So this is 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Okay. And then times, we're using 7. 7 times, that is 49, right? 7 times 7 is 49. So we determined that the area would be this. So your output would return whatever this rectangle gets you, right? But how do we determine what this rectangle is? That's the question here. So for this question, it's basically the tallest height in the array at an optimal point such that it finds the second height, which also returns the most value. For example, if you did this, you would get 1, 2, 3, 4, 5 times 8, which is 40. But instead you use this one where you get 49, even though the height is not as much, the indice is 2 more, which causes greater value, right? So if we're looking through an integer, we want to use pointers. So we're going to do L r equals 0 and the length of height, right? Length of height minus 1. And then we want, so we will be calculating a new value of water, but we need to have a base value, right? So something equals 0. So let's just say max water equals 0. Okay. So normally for a pointer solution, you have something written like something like this. So while L is less than or equal to R, but I assume to have a container, you can't have anything equal to. You can only have something less than. You can't have equal to because you can't have this times this. I'm like, that means like say this is an indice, right? Indice 1, right? This was indice 1 with the height of 8, right? So you take a height of 8, and this becomes 8. You can't just have this because this is not 1 times 8. This is nothing. This is technically, in a container, this is one side of the wall. It's technically nothing. You need these 3 values. You need this to have a closed. You need a closed area. This will hold the water. This won't hold the water. This will just be 1/4 of the thing that can hold the water, right? So it would be this. So while it still is searching for 2 valid parameters, we're gonna have a given area, right? Area equals, and we determined that area would be the width times the length. So in this question, we have the width as indices, and the indices are these two. So we will end up with these two, right? So we could say, just go r minus L, because we'll have a positive value in doing so, right? And then we'll multiply this by the height. Now for height, you can't just say like multiplied by height, because the input value, the input array is height. Like that's height. So you can't multiply all that by the entire input array. You can't multiply this by every single value here. That's what that was saying. You can't do that. You need to do it by the value of what L or R is. But even in that, I think this is asking us to do for the smallest value in M, for the smallest value between R and L. So that would look like height. So it would look like the smallest value would be min height L, so height R, right? Because you can't have this container here, like you can't have this closed value, because this is not an actual container. It can't hold anything. It has to be from here, and this is the minimum of pointer R and pointer L. So that's what we have here. And then what we need to do is, as it's going through the whole thing, it calculates this area for every possible combination, and it'll append it back to the maximum, right? So this is the value being changed, but how is it being changed? I think we'd have to use the maximum function. It'll be maximum x and y. So it's max x, y. And how this works is maximum x is considered to be the current maximum already, max water. So for the first time, it would find anything would be 0, right? So this would be 0. So then it would automatically take the max of whatever this roots to be, which it will take as area. Area for everything. So it'll keep going until it finds max water. And every time it looks through, so it'll look through this and this, right? And it'll append it, because it'll be maximum of 0 versus this. And it'll look through this, look through this, it'll be greater. Look through this, it'll be greater. And it'll be the most here. So it'll append this. So but then we have the conditions, so that we need to keep looking if something is less than the other thing. So we're looking at the heights especially, because that's what we need to look at, right? So this would go back to the height values, because the pointers are always moving, but now we need to compare the height to get the most contained area, right? So now we're looking at something like height of R, or let's do height of L is less than, if height of L is less than height of R, we want the left pointer to equal L plus 1, right? So if left is less, so for example, if it was this and this, or say for this and this, you want to have this keep going till you find this, then it's holding more water, right? Or you find this, then it's holding, I don't know if it'd be more water, but that's the gist of it. But if it's not like this, then the else would be if height of L was greater than height of R. And so for this one, if you move the left pointer, if you're adding to the left, you can do right equals R minus 1. But let's combine these. So right equals 1, and for this one, do L plus equals. And what this means is the opposite of this. So for example, if left is less, then you're moving left this way. But if right is less than, so this one and this one, so for this one and this one, yeah, you subtract it. You move the indice to the left. You're reducing the indice, so it's going this way. So for example, for this and this, or for this and this, it's small. So you'd move it. So you have this one now. So it'd be this. And so this would have more value, right? So that's what we're looking for here. And this is just while L is left in R, right? But entirety in the whole formula, we want L to be moving regardless by the same indice, and then R to be moving as well. And then, so this means that while L is less than R, right? It's moving, but we don't have something that's moving these outside of the while bracket. We need something to move these in regards to everything in general. So they need to keep being moved even if the while bracket is false, right? We need to look through the entire array to find all possible combinations. So then after we do that, we just return the given value of the water, which we're constantly appending to be max water. And I believe this should give you a solution that looks to everything in an optimal method. Yeah, so let's try to submit it. And there we go. That appears to be the optimal solution. Thank you.